Welcome to this explainer. Today, we are going to completely bridge the gap between abstract AI theory and hands-on practical application. You know, AI agents are rapidly evolving from mere industry buzzwords into the absolute standard for modern engineering. If you've been hearing all the hype around these systems, but aren't entirely sure how they function under the hood, or better yet, how to actually build one yourself, well, you are in the exact right place. We're going to unpack the core mechanics of how these systems think, and then we're going to build a highly robust multi-agent system completely from scratch using Google's SDK.
So here's our roadmap for today. First, we'll look beyond traditional AI chatbots. Second, we'll explore how AI agents actually think. Third, we are building your very first agent. And fourth, we'll put it all together into a working application.
All right, part one, beyond traditional AI chatbots. This is about being way more than just an answering machine.
Stick with me through the high-level concepts first, because I promise we are really going to get our hands dirty and build a working app by the end of this explainer. We need to start by drawing a hard line in the sand regarding what makes this technology so radically different from what you're probably used to. Consider a standard chatbot, right? If you ask it for a dinner idea, it generates a recipe in one single go, and then it completely stops. It's done. An agent, however, is an autonomous problem solver. If you give an agent that exact same prompt, it might look at your request, check your digital fridge inventory, plan a meal based on what's expiring soon, call a grocery API to order missing ingredients, and finally confirm the delivery time. It has reasoning, planning, and memory. It has enough autonomy to actually make decisions on your behalf.
Moving right along to part two, how AI agents think. It all comes down to reasoning and acting. To really understand how these agents pull this off, we have to look at the underlying logic driving them. The whole foundation of modern AI agents traces back to a simple but incredibly powerful research paper titled React. You see, early language models suffered heavily from hallucination loops because they just spat out text in a single breath, just predicting the next word without any real-world grounding whatsoever. The React framework totally solved this by explicitly synergizing reasoning and acting. It literally forced the models to pause, articulate a logical thought process, and then interface with reality before responding. This creates the absolute heartbeat of an agent, a continuous dynamic loop. Step 1, they reason step by step. Step 2, they act, like actually calling a specific tool or API. Step 3, they observe the real-world results of that action. Now, this observe phase, that is the critical differentiator. Instead of blindly executing and just hoping for the best, the AI stops to read its environment. It checks, hey, did that API call actually work? Or did it return a 404 error? It grounds its next decision in reality. And finally, step 4, they adjust and decide their next move. This cycle just repeats until your ultimate goal is fulfilled.
But keep in mind, not all agents follow the exact same playbook. Depending on your problem, agents generally fall into one of three patterns, and choosing the right one is all about trade-offs. First up, sequential agents. These are literally like an assembly line. Step 1, then step 2, then step 3. Highly predictable, super low computational cost, but very rigid. Next, reactive agents. These are highly flexible and adapt in the moment based on the current state. They constantly ask, what should I do right now? They adapt beautifully, but all that decision-making increases latency. And finally, planning agents. These are the heavy lifters. They pause, sketch out a holistic plan, and then execute. Think of it like booking travel. You don't just randomly buy a flight. You plan the dates, then the flight, then the hotel. They have a high computational cost up front, but for multi-step goals with complex dependencies, planning agents are absolutely the way to go.
All right, part 3, building your first agent. Let's get into a step-by-step guide. Let's actually move to the code and see how this builds into a practical multi-agent blog writing system. We are going to build an application that takes a topic, plans an outline, and writes a fully fleshed out blog. To get started, you just need 3 straightforward prerequisites. First, we'll use UV for lightning-fast Python package management. This is going to save you incredible amounts of setup time. Second, we install the Google SDK or the Agent Development Kit, which is going to handle all the heavy lifting of the underlying architecture. And finally, you simply create an agent file in your IDE. Before we write the logic, I really want you to picture the structure. Think of our code architecture exactly like a set of Russian nesting dolls. We're going to have smaller, highly specialized agents safely wrapped inside larger, controlling workflow agents, which are then finally wrapped inside one main coordinator. What makes this architecture so brilliant is the state management. These dolls don't operate in total isolation. They share a secure, localized memory state. This ensures that critical context is never, ever lost as tasks are passed back and forth between the outer and inner layers of your application.
Our smallest nesting dolls handle the planning phase. First, we have the blog planner. Its sole job is to take a topic and generate a structured markdown outline. We explicitly tell it to include a title, an intro, 4 to 6 bulleted sections, and a conclusion. Then, we have its partner, the outline validation checker. Now, this agent doesn't write anything. It acts as a ruthless editor who refuses to let a single missing bullet point slide. It checks the generated outline, and if everything is perfect, it simply answers OK. But if even one piece is missing, it flat out answers retry and explicitly explains what went wrong so the planner can fix it.
So, what do we do when that ruthless editor triggers a retry? Well, we wrap both the planner and the checker into a workflow agent called a loop agent, specifically our robust blog planner. And we cap this loop at a maximum of 3 retries. Why exactly 3? It creates an automatic safety net. It allows the model to self-correct without human intervention while crucially preventing infinite loops. Capping the retries protects you from runaway API costs just in case the model gets fundamentally stuck on a single task.
With a perfect outline securely saved in our shared state, we move right into the drafting phase using that exact same safety net mechanism. For the blog writer, we use highly specific prompting. We tell it to assume the audience is software engineers, to completely skip the basic fluff, to focus on practical insights showing the how and why, and to use actual code snippets. Assigning specialized personas like this is an absolute best practice in multi-agent system design because it tightly restricts the scope and drastically improves output accuracy. A dedicated blog post validation checker then reviews the written article against the outline for clear explanations and a solid conclusion. Again, we wrap these two into a second loop agent called the robust blog writer, letting it self-correct up to 3 times.
Which brings us to part 4, putting it all together, the final assembly.
We have all our individual pieces beautifully structured, so now it's time to assemble the final, largest nesting doll. We expose those loop agents, the robust planner and the robust writer, as executable tools. Then we just hand those tools to our root agent, which we will simply call Blogger. To the root agent, that entire complex looping, validating, and retrying process we just built simply looks like a single, highly reliable API endpoint. Blogger's instructions are wonderfully straightforward. Step 1, call the planner tool to make an outline. Step 2, call the writer tool to draft the post. Step 3, add 3 alternate titles. And Step 4, add 2 tweet-length hooks. By restricting the root agent to just these specific tools, the overarching workflow remains completely controlled.
And honestly, the best part is that executing this isn't some complex deployment nightmare. Once your script is written, you simply launch it directly in your terminal using the add web command. This instantly spins up a super clean local web interface right in your browser. You can type in a prompt, something like top 10 use cases for AI agents, and the magic begins. You aren't just getting a prepackaged answer. You are literally watching a team of AI subagents debate, draft, reject, self-correct, and rewrite in real time until they deliver a highly polished final result. You've just successfully crossed the bridge from theoretical concepts to structuring and building a robust, self-correcting multi-agent system from scratch, utilizing Google's SDK. You've seen exactly how wrapping specialized agents with strict checkers inside looping workflows creates incredibly reliable software. Which leaves just one incredibly exciting question for you to answer. Now that you actually understand how these agents reason, act, and adapt, what are you going to build next?